On the border between Switzerland and France, just outside Geneva, there is a tunnel. You cannot see it from the surface. It runs approximately 17 miles in a circle, buried about 100 meters underground, beneath farms, beneath roads, beneath the Alps on the horizon. Inside that tunnel, scientists from more than 100 countries accelerate subatomic particles to nearly the speed of light and then smash them into each other. What they are looking for in the debris of those collisions are the most fundamental secrets of the universe. This is CERN, the European Organization for Nuclear Research. And tonight on Words with Wentz, we are going to explore what it is actually doing. Not the rumors, not the conspiracy theories, the documented science, which is honestly more extraordinary than most of the rumors, because the real story of CERN includes the discovery that explained why matter exists at all. It includes the invention of the internet you are watching this on. It includes ongoing experiments that may tell us what 27% of the universe is actually made of, something that has never once been directly detected. I find CERN one of the most genuinely astonishing things humanity has ever built. Let me show you why. The Large Hadron Collider is a circular tunnel approximately 27 kilometers, about 17 miles, in circumference running beneath the French and Swiss countryside. Inside that tunnel, powerful superconducting magnets, cooled to colder than outer space, guide two beams of protons traveling in opposite directions. Those beams are accelerated until the protons reach 99.99991% of the speed of light. Then the beams are steered into each other. The collisions are extraordinarily brief, but for a fraction of a second, they recreate conditions similar to those that existed in the universe, fractions of a second after the Big Bang, conditions of temperature and energy density that have not naturally existed in the universe for approximately 13.8 billion years. Sensitive detectors surrounding the collision points, some as large as a multi-story building, record what emerges from those collisions in extraordinary detail. Teams of physicists around the world then analyze that data, searching for particles, behaviors, and phenomena that can test or challenge our best theories about how the universe works at its most fundamental level. What they are testing is called the Standard Model of Particle Physics, the most precisely verified scientific theory ever developed. It describes the fundamental particles that make up matter and the forces that govern their interactions. In 2012, CERN found the piece the Standard Model had predicted but never directly confirmed, and what they found changed what we know about why anything exists at all. On July 4, 2012, scientists at CERN announced the discovery of a new particle consistent with the Higgs Boson. Peter Higgs, the Scottish physicist who had theoretically predicted the existence of this particle in 1964, was in the auditorium when the announcement was made. He wept. Let me tell you why that moment mattered. For decades, physicists had believed in the existence of something called the Higgs field, an invisible field that permeates all of space. The theory said that certain fundamental particles, as they move through this field, acquire mass. Without the Higgs field, particles would have no mass. They would travel at the speed of light. Atoms could not form. Stars could not ignite. Planets could not coalesce. You and I could not exist. The Higgs boson is what you detect when you disturb the Higgs field. Finding it confirmed that the field exists, that the mechanism by which matter acquires mass is real and measurable, not just theoretical. Peter Higgs and François Englert received the Nobel Prize in Physics in 2013 for the theoretical work that predicted it. The award came 49 years after the prediction. The discovery did not answer every question. It confirmed one of the most important ones, and it opened new ones, because the Higgs boson that CERN found behaves slightly differently than some versions of the theory predicted. That difference is a trail. Physicists are still following it. The scientific discoveries at CERN are extraordinary on their own terms, but CERN has also produced something that changed daily life for every person on the planet, and most people have no idea it came from there. In 1989, a British scientist named Tim Berners-Lee was working at CERN as a software engineer. The problem he was trying to solve was practical and specific. CERN employed thousands of researchers from dozens of countries, working on dozens of different experiments, using different computers that could not easily share information with each other. His solution was a system of linked documents that could be accessed through a network. Documents that could reference each other through what he called hypertext links. He called it the World Wide Web. CERN made that technology freely available to the world. No patents, no licensing fees. The web was a gift. The internet you are watching this on, the web browser, the hyperlinks, the basic architecture of how information travels across the global network, traces directly back to a particle physics laboratory in Switzerland, to a practical problem about how scientists could share their data. The benefits did not stop there. Technologies developed for particle physics have improved medical imaging. The precision detectors designed to track particle collisions have found applications in cancer diagnosis and treatment. Superconducting magnets developed for the LHC have applications in MRI machines. Advanced computing systems built to process the enormous data output of CERN experiments have contributed to progress in distributed computing and data science. The history of fundamental science is full of discoveries that seemed purely theoretical until they weren't. CERN has attracted its share of rumors over the years: black holes, portals to other dimensions, attempts to contact dark forces, conspiracy theories about what is really happening 100 meters underground near Geneva. I want to address these not with dismissal, but with something more interesting: the actual science. The most persistent concern is that the LHC could create a black hole that would swallow the Earth. CERN has addressed this directly and in detail in its public safety documentation. Here is the core of the scientific response. The Earth's atmosphere is constantly being bombarded by cosmic rays, high-energy particles arriving from space. Those cosmic rays routinely produce collisions with energies comparable to, and in many cases greater than, those produced by the LHC. This has been happening for as long as the Earth has existed, approximately 4.5 billion years. The Earth, the Moon, the Sun, and countless other astronomical bodies throughout the universe have been exposed to cosmic ray collisions at these energy levels for billions of years, and here we are. The rumor that the LHC could destroy the Earth is not consistent with the evidence of the universe itself, which has been conducting comparable experiments continuously for billions of years without incident. I understand the impulse behind the rumors. There is something genuinely mysterious about a machine that recreates conditions from the first fraction of a second of the universe. Mystery invites speculation. But the real mystery, dark matter, antimatter, the nature of space and time at the smallest scales, is genuinely more interesting than any conspiracy theory. And it is documented. The Higgs Boson was found. The Standard Model was confirmed in one of its most important predictions, and the questions got bigger. Here is where CERN's research stands today: dark matter, cosmological observations, the way galaxies rotate, the way light bends around massive objects, the large-scale structure of the universe, all suggest that approximately 27% of the universe is made of something that does not interact with light and has never been directly detected. We call it dark matter because we cannot see it. We know it is there because of its gravitational effects. We do not know what it is. The LHC is searching for it. for any particle or interaction that might explain what 27% of the universe is actually composed of: antimatter. The laws of physics, as we currently understand them, suggest that the Big Bang should have created equal amounts of matter and antimatter. Those equal amounts should have immediately annihilated each other, leaving nothing. And yet, here we are. The universe is made almost entirely of matter. Something, somewhere in the first moments of the universe, created an asymmetry that allowed matter to survive. CERN is trying to find what that something was. These are not small questions. They are questions about why the universe exists at all, why there is something rather than nothing, why matter survived, and what the invisible scaffolding of the cosmos is actually made of. CERN will not answer all of them, but it is asking them, rigorously, collaboratively, with evidence, in the most ambitious scientific instrument humanity has ever built. CERN was founded in 1954, 9 years after the end of the Second World War, by 12 European nations that had spent the previous decade trying to destroy each other. The idea was deliberate and specific: use science as a reason to cooperate, give the best minds of nations that had been at war a shared project, a shared question, a reason to work together rather than against each other. That founding intention has held. Today, more than 100 countries send scientists to CERN. They speak dozens of languages. They come from nations that are political rivals, economic competitors, and occasionally official adversaries. At CERN, they share data, challenge each other's findings, and build on each other's work. And in pursuit of that cooperation, they invented the Internet. They found the particle that explains why matter exists. They are looking for what 27% of the universe is made of. I keep coming back to something that I find genuinely moving about CERN. It is the largest scientific instrument ever built, and its purpose is to ask the most fundamental question a conscious mind can ask. What is all of this? What is the universe made of? Why does it exist? Why does anything? Those questions do not have complete answers yet. CERN is the most serious attempt in human history to find them. And the fact that human beings built it, that we dug 17 miles of tunnel beneath the Alps, cooled magnets to colder than outer space, and sent protons hurtling toward each other at 999% of the speed of light, just to understand what we are, I find that extraordinary. But here is something I cannot stop thinking about. The deeper CERN goes, the more precisely they measure the universe, the more precisely ordered it turns out to be. The physical constants that govern the universe, the strength of gravity, the mass of the electron, the speed of light, are tuned to values so specific that if any one of them were even slightly different, atoms could not form, stars could not ignite, life could not exist. Scientists call this fine-tuning, and it is one of the most documented and least resolved questions in all of physics. Dark matter, 27% of the universe, never directly detected, something immense and invisible shaping the structure of the cosmos from the outside. Antimatter. The math says the Big Bang should have created equal amounts of matter and antimatter, leaving nothing. And yet, here we are. Something tipped the scales. Something allowed existence to survive. And I find myself thinking that the places where science runs out of explanation are precisely the places where theology has always lived. Not as opponents, as companions asking the same question from different directions. Science asks, what is the universe made of? Theology asks, why does it exist at all? CERN has not answered the second question. The Higgs Boson confirmed that an invisible field permeates all of space and gives matter its mass. And that discovery did not close the mystery, it deepened it. Maybe the universe is not a problem to be solved, maybe it is an invitation. The documents are in the description. This is Words with Wentz. Know the truth.
Let the signal cut through the noise, reading between the lines. Every story leaves a trace, unlocking time and space, finding truth with Wentz. Words with